Our stance on the usage of chemicals in forensic science is that luminol should be used instead of silver nitrate. Luminol is not poisonous. However, when reacting with hydrogen peroxide or sodium peroxide, it can be dangerous, but this is not the case in crimes. The hazardous reasons onto why silver nitrate should not be used is because it can cause skin burns and eye irritation.
Luminol has a molecular formula of C8H7N3O2 with a molar mass of 177.163 grams per mole. It has a hybridization of sp2, 3 sigma bonds, 1 pi bond, and its Vesper shape is trigonal planar. Silver nitrate has a molecular formula of AgNO3. It is made up of various components that make it a polyatomic ion, such as the metal from the silver, the non-metal from the nitrate, and nitrogen plus oxygen, which is found within the molecular formula. It has a molar mass of 169.87 grams per mole, has 1 pi bond, 3 sigma bonds, a Vesper name of trigonal planar, sp2 hybridization, and it is polar, because Ag has the electronegativity of 1.9, nitrogen has an electronegativity of 3.5 or 1.1, and NO has the electronegativity of 3.5 or 1.1, making the molecule polar. Is luminol useful? Yes, but why? Crime scene investigators can use luminol to find traces of blood that may have been removed or cleaned up from the scene. The iron in blood reacts with and catalyzes the luminol, and only a small amount of luminol is needed to create a reaction that doesn't release toxic fumes, but instead simply glows in the dark. In 1939, scientists from San Francisco studied the efficiency of luminol and discovered that each application glow, although only lasts for 30 seconds, may be easily reproduced by applying a fresh luminol hydrogen peroxide solution. And biologists can also utilize luminol to detect a poison like cyanide. Also, luminol is fairly cheap to purchase, and it doesn't mess with or change the existing DNA.
Forensic investigators use luminol to detect trace amount of blood at crime scenes. As it reacts with iron in hemoglobin, biologists use it in cellular assays to detect copper, iron, cyanides, as well as specific proteins via Western blotting.
Luminol is used as a method to detect traces of blood in a crime scene, which gives information about the assailant and what he or she did after the attack. The assailant could have cleaned up the crime scene, such as blood, which is what luminol will detect. Sodium hypochlorite will then be reacted with luminol to create an emission of light or a glow to show where traces of blood are at in the crime scene. This can also reveal faint bloody shoe prints. The luminol reaction results when an oxidizing agent, such as blood, catalyzes the oxidation of luminol by hydrogen peroxide in a basic solution. Sodium hypochlorite, also known as bleach, which is an oxidizing agent. Certain metals, plant peroxidases, cause luminescence with luminol. Spatter patterns can help investigators locate the point of attack and what sort of weapon was used. Nitrate is used to reveal and collect fingerprints on paper for criminal and medical investigations. Silver nitrate is also used as a spray or a dip and will either be in a stick form or liquid form diluted into H2O. This corrosive chemical substance is made from silver and nitric acid. When silver nitrate is used for fingerprints on paper, silver nitrate is sprayed onto the fingerprint where it reacts with the chlorides to give the insoluble silver salt, silver chloride. Porous objects found at the crime scene involves a number of different methods. Whether the substrate being examined is paper, wood, leather, or some other porous material, a particular procedure must be followed for the best results. The procedure begins with iodine fuming, followed by 9-hydrin, and then silver nitrate or physical development reacts with salt to produce a dark-colored residue. Since salt is often part of the Latin print residue, this reaction allows another way of development or an enhancement of prints. If salt is present in the substrate, the entire object will darken. Silver nitrate reacts with light to darken also.